Okay, let's dive in. You rely on digital services for basically everything now.
Everything, yeah. Banking, messaging.
Organizing your life,
Yeah.
keeping track of passwords, maybe.
Ugh, passwords. Always passwords.
Right. But it often feels like this trade-off. You get the cool service, but you're handing over all this sensitive info
Mm,
to some company that, might get hacked. Like
exactly.
we saw looking at one of our sources here just this week with that huge password manager incident.
Mm-hmm.
It's just a really clear reminder, isn't it?
Yeah.
Centralized data. It's a juicy target, a single point of failure.
It really underscores this fundamental tension we have online. We want these amazing connected tools, but the way things are built now, it often forces you into a corner.
Functionality versus privacy.
Right. It's either all out there or it's locked away with some company you just have to, well, trust.
Exactly. And, that tension, it even exists in the blockchain space, which is kind of ironic given the whole decentralization idea.
Because most chains are just public.
Totally public.
Hmm.
Transactions, balances, smart contract stuff. Anyone can look it up.
Yeah.
So what if you could actually combine that decentralized ledger idea with, like, real data privacy?
Hmm.
That's what we're getting into today. We're looking at Secret Network. It's a blockchain built specifically for confidential computation.
Yeah, and our goal here, digging through the sources provided, which cover everything from the basics to some pretty deep technical stuff, is to really understand the core tech, what makes Secret Network private.
And what does that actually let you do for dApps, for you as a user?
Exactly. What does it unlock?
I'm really curious about how they built this privacy on top of, standard blockchain tech.
Mm-hmm.
It seems like they're using a solid foundation, but adding something genuinely new.
And that's a key point from the material. They're not trying to reinvent everything from scratch. They're using established, pretty battle-tested blockchain tech, like from the Cosmos ecosystem, and then adding this unique privacy layer right into how things are processed. It's more additive, tackling privacy directly.
All right, so let's talk about that foundation then. The sources say Secret Network is a sovereign L1 chain, Cosmos ecosystem. For someone who already gets blockchain basics, what's the main thing to grasp about its core structure?
Okay, the key thing for you, knowing the landscape, is Sovereign L1 in Cosmos means it uses the Cosmos SDK, that's the toolkit for building the chain, and Tendermint for consensus.
Right, Tendermint.
So think delegated proof of stake, validating blocks using Tendermint's Byzantine Fault Tolerance, or BFT.
Okay, so not the, 51% attack scenario we sometimes hear about.
Yeah.
What's different about Tendermint BFT and how Secret uses it?
Yeah, this is super important, especially for a privacy-focused chain. Tendermint BFT needs a 2/3 majority, 66% of the validator voting power to agree on a block.
66%. Wow.
Sure. Yeah. If they can't reach that 66% consensus, the chain actually halts temporarily, stops processing transactions.
Huh. So it puts safety,
Yeah.
way above just staying online constantly.
Precisely. It trades that continuous liveness, as it's called, for much stronger security guarantees. Think about it attacking the chain, getting fake data accepted. You'd need to control 2/3 of the stake.
Which is way, way harder than just over half.
Much harder, much more expensive. So that strong consensus is really the bedrock, especially when you plan to handle sensitive, private information.
Got it. Okay. Solid foundation, high security threshold.
Hmm.
Now, the really tricky part, how do you add privacy to a system where data usually gets copied across tons of nodes?
Right. This is the core innovation, and it's detailed really well in the sources. It's not just one thing, it's a combination. You've got encryption, you've got trusted execution environments, TEEs, and specific access controls.
Okay.
The basic idea is to process data where the inputs, the computation itself, and the outputs stay encrypted pretty much the whole time.
Encryption makes sense, obviously.
Right.
Scramble the data. But how does a node compute on data it can't actually read? That's always been the puzzle, right?
Exactly the puzzle, and that's where TEEs come in, trusted execution environments. The sources specifically mention Intel SGX as the tech used.
Intel SGX. Okay.
Think of a TEE as like a secure vault, a protected area right inside the computer chip itself.
Like a black box on the processor.
Pretty much. Code and data that go inside the secure enclave are protected. Even the person running the server, the node operator, they can't see inside. They can't mess with what's happening in that secure zone.
Whoa. Okay, so the encrypted data goes into this secure hardware box for computation.
Yes, that's the magic step. The network nodes running the special TEE hardware get the encrypted data, they pass it into the TEE. Inside, it might be temporarily decrypted for the actual computation, but crucially, it never leaves that secure enclave in a readable state.
It stays protected.
Stays protected from the node operator. Then the result gets re-encrypted before it leaves the TE and gets written back to the blockchain.
This kind of mind-bending. The network validates the work, but the nodes doing the work never see the raw data.
Correct.
So how does the rest of the network trust that one node's T isn't, compromised or faking it?
Good question. That's handled by something called remote attestation.
Remote attestation.
Yeah, it's a cryptographic process. It lets other nodes verify that a specific T is genuine hardware, that it's set up correctly, and that it's running the exact approved code it's supposed to be running. It's like a hardware-backed proof of integrity.
Okay. So the nodes compute privately, the network can verify the environment is secure. But what about me, the user?
Yeah.
If my balance is encrypted, how do I see it? How do I interact with my own private stuff?
Right. Crucial point. That's the access control layer. Your sensitive data, say your token balance or transaction details, it's encrypted on the chain by default.
Okay.
To see it yourself, you use something called a viewing key. It's a key you hold that lets your wallet or application decrypt your data, client side.
So only I can decrypt it with my key.
By default, yes. But what's really powerful is you can also generate special limited keys, they call them permits sometimes, or specific viewing keys to grant temporary or specific access to others.
So I could let, say, an auditor see just one specific transaction, or let another app read my balance for some DeFi thing.
Exactly. You choose who sees what and when. It's selective disclosure, controlled entirely by you.
That's fundamentally different. It's not just hidden from everyone. It's hidden by default. And I hold the keys to grant access. That really flips the power dynamic compared to, well, almost everything else online.
It absolutely does. It puts data control back in your hands, even though the data lives on this shared decentralized network. So you put it all together.
Yeah.
You've got the secure Tendermint base, the end-to-end encryption, the T's like SGX doing the private computation verified by remote attestation, and then the user-controlled access through viewing keys and permits. That whole package is what the sources call the confidential computing layer.
Okay. Wow. So we have this blockchain, decentralized, super secure with that 66% rule, computes privately using TEs, user controls access. What can you actually build with this? What does this privacy enable?
Well, it opens up a totally different world for dApps, right? You're not limited to just transparent stuff anymore. You can build private smart contracts.
Private contract.
Yeah, using CosmWasm, which is their smart contract platform. It means that the contract's internal logic, its data state, that can all be kept confidential from the public.
And you mentioned private tokens earlier.
They have the SNIP20 standard. Think of it like the common ERC20 or CW20 token standards, but with privacy built in.
SNIP20. Okay.
It allows for tokens where your balance and the amounts you send or receive are encrypted by default.
Okay, that's huge for DeFi, right?
Yeah.
Or just personal finance. On most chains, everyone can see your wallet, see your trades.
Absolutely. Imagine private payments, keeping your investment moves confidential, private salary payments. It changes a lot for finance use cases.
Definitely. What else?
Well, beyond tokens and contracts, the sources talk about things like SecretVRF.
VRF, verifiable random function.
Exactly, but a private one.
Wow.
It generates randomness on-chain that's verifiable, but the process and the seed remain hidden until the result is revealed.
Okay, so for things like gaming, like loot boxes, you don't want people predicting the outcome.
Precisely. Gaming, decentralized lotteries, anything needing unpredictable but provably fair outcomes without revealing the mechanism beforehand. The materials list a bunch of areas: DeFi, obviously, gaming, data marketplaces.
Data marketplaces, how would that work?
Well, imagine being able to let someone run computations on your sensitive data without them ever actually seeing the raw data itself. You just sell access to the result.
Whoa, okay.
Yeah. Private voting systems, secure communication, lots of possibilities.
So it really boils down to enabling use cases that just need confidentiality, which, let's be honest, is most real-world stuff, enabling those on a blockchain without giving up the privacy part.
Yes. And maybe this is the question for you listening. How does having confidential computing built in actually change the game? What kinds of dApps become possible that just couldn't exist on a fully transparent chain?
Yeah.
It moves way beyond just recording who sent what to whom. It allows for apps that handle truly sensitive user info, run secret business logic, facilitate private deals, all with blockchain's integrity underneath.
It really does feel like It addressed that core problem we started with, services versus privacy, but using decentralization and confidentiality together.
Yeah, and it makes you wonder, right? Is this kind of confidential computing layer going to stay niche, or will it become maybe essential as more complex, sensitive stuff moves onto blockchains?
Hmm.
It definitely has challenges, secure implementation, making sure the Ts are truly trustworthy, but the potential is huge. Building digital interactions that are private, secure, and decentralized in ways we couldn't before.
Totally. It changes how you might think about a future decentralized Web 1 where privacy isn't some awkward add-on, but it's just baked in from the start.
Indeed, a different paradigm.
Well, that was seriously fascinating, really unpacking the secret network tech stack. Starting with that solid Cosmos and Tendermint foundation. That 66% consensus is key.
The security base.
Then layering on the encryption, the hardware TEs like SGX for the actual private processing, verified by that remote attestation.
Right.
And finally, the user control through viewing keys and permits. You can really see the whole picture, how it enables these new kinds of dApps where privacy is fundamental, not optional.
It's a really interesting hardware-boosted way to tackle a major hurdle for blockchain in many real-world applications.
Absolutely. Well, thanks for joining us on this deep dive. As you, listening, think about decentralized tech in your own data online. Maybe consider what this kind of privacy unlocks. Using decentralized systems without broadcasting your private life. What could you build? What services could you finally feel comfortable using if confidentiality was guaranteed?
Definitely something worth thinking about as this digital world keeps evolving.
Until next time.